Maggie. I come from Santa Fe, New Mexico, and let's just get this thing started. Did you know that you could become years older than your twin?
We didn't!
Yup, I actually have a twin, which works out perfectly for this video.
Hi guys! Bet you didn't know that!
Anyways, in a nutshell, the twin paradox isn't actually a paradox at all, and I'm about to tell you why in the next 2.5 minutes. The solution is basically that time travels more slowly the faster you travel through space. I know. It sounds really confusing, but I'm about to break it down for you really quick. We just need to understand one basic postulate of special relativity, and that's inertial reference frames. And this means that all laws of physics will always hold true from any perspective or frame of reference whenever that reference frame is inertial or undergoing uniform motion. So for instance, let's say I'm actually sitting in a car right now going at a constant velocity. It's moving, right? But could you tell from our previous frame of reference? Nope. And that's just because we couldn't see out the window. And so just know that you can only tell you're moving relative to something else. So if I travel into space at a speed close to light while my sister stays here on Earth, after I take off, it appears to my sister that I'm moving and she's stationary. So for her, a second on her clock looks something like this, while a second on my clock looks something like that. Or traveling at a longer distance between each second, suggesting to my sister that time is going slower for me than it is for her. But on my end, due to the law of inertial frames, it appears that I'm stationary and my sister is moving, suggesting the exact opposite. Time is going slower for her. Enter the paradox. We both can't be right. And the truth is, I, the space twin, am wrong and I become the younger one. But why? As you may remember, special relativity only applies to inertial reference frames, which only travel at a constant speed or velocity. But my trip to space isn't always at a constant velocity. On my return home back to my lovely sister, I turn around and accelerate, disrupting the constant velocity I was at initially. And so all of that special relativity stuff doesn't even apply to me anymore. And now we enter general relativity. And according to general relativity, time moves slower in accelerating reference frames, meaning that I don't age as quickly as my sister when I'm accelerating through space. Okay, picture a graph of my speed compared to my sister's stationary speed. First, I travel into space, and then I travel back. And because of general relativity, since I'm accelerating, it's going to take longer for one of my seconds to go than for one of hers. It only takes me about 12.8 seconds instead of her 20. And that's because, due to general relativity, my time slows down and loses to hers during my turnaround. So I do in fact age less than she does. So there you have it. That's the quirk to the twin paradox. It's the difference between special and general relativity.
Thank you guys so much for watching my video. Bye!